What are the challenges affecting the progress of nuclear fusion? This video is all about the challenges affecting the progress of nuclear fusion, therefore keep watching until the end and make sure to subscribe along with ringing the bell icon. Nuclear fusion is not just something new that scientists are trying to their best to make use of it. Instead, nuclear fusion is something that will, if means of execution are effectively structured, will give the world a new way to grow and develop. While nuclear fusion is something that has countless benefits and solutions to our existing problems, it does bring some considerable challenges associated with it. However, you might be wondering what even is nuclear fusion. So in simple terms, it's a method of joining together two or more atomic nuclei to form one or more atomic nuclei. Now, you might think, how does this benefit us, right? Then let me tell you that this process releases energy that can be used to boost development. However, things are not as simple as they have just sounded. But before we move further, let me just tell you something very interesting. If nuclear fusion is made possible by scientists by uncovering and devising an optimum method of executing nuclear fusion, all our energy crisis will be finished, as the amount of energy produced by nuclear fusion is several times greater than our current energy production methods. Moreover, our climate will benefit the most, as nuclear fusion has no waste that harms the climate like greenhouse gases. Additionally, humans will be set free from the worry of running out of finite vital resources, because fuel for nuclear fusion is extremely common, such as hydrogen. So the chances that nuclear fusion will dramatically change the world are high. Nuclear fusion is the most effective source of energy generation adopted not on Earth, but throughout the universe. Big celestial bodies such as our own sun even use fusion to generate thermal energy, which we use on Earth to support life. But why is nuclear fusion a promising source of energy generation? Well, that's because this process has no carbon emissions, and on top of that, its percentage of mass to energy conversion is simply convincing, which implies that nuclear fusion is a source of energy generation both environmentally and commercially friendly. Although there are many organizations throughout the world claiming to have found ways to commercialize the method, the set of challenges associated with the process simply tells us that commercial use might not be possible anytime soon. Not just this, but nuclear fusion is also used in atomic weapons. In today's world, nuclear fission is already a widespread method being utilized efficiently. The process is all about unstable atoms splitting apart to become more stable, a process that releases energy. As atoms split apart, more neutrons are released, which are then further absorbed by other atoms, which repeat the entire process, and the reaction carries on indefinitely, which produces great amounts of energy. If this chain reaction is controlled, then it can be used commercially to great advantage. However, reactions that are uncontrolled would result in atomic explosions that can be severely damaging. Control over nuclear fission reaction is achieved by absorbing the number of neutrons, along with altering their speed, which has allowed the method to be used safely. If similar control is found possible with nuclear fusion, then nuclear fusion is a process that releases enough energy to replace all other energy production methods as the main source of electricity generation. All processes of energy generation on Earth, such as burning fossil fuels, wind, solar, and even nuclear fission, promote concerns such as lack of resources, availability, or even worse, environmental impacts which the world is currently suffering from. However, nuclear fusion is the ideal method, as its primary fuel source are extremely common elements like hydrogen. On top of that, nuclear fusion produces no waste to harm our climate either. Therefore, it's an incredible energy generation method, but the question is, can we control it? However, before the world even worries more about controlling it, there are other problems that scientists are greeted by when thinking about nuclear fusion reactions, and that is, starting a nuclear fusion reaction is not an easy task. Because as we all know, naturally nuclear fusion can be observed taking place in our sun, and we know that exceedingly high temperatures and pressures enable the fusion reactions to take place in sun, which is achieved by the sun's immense force of gravity, something the Earth doesn't have. Therefore, to start nuclear fusion reactions on Earth, unimaginably high pressures and temperatures such as up to 100 million degrees Celsius would be needed. Moreover, if we are able to do it somehow, the next challenge to consider is that if our intention with fusion reactions is to produce more energy than required to start the reaction, then it would result in a bomb, because energy production levels of fusions are extremely high. In order for nuclear fusion to be a viable energy production source, a break-even state must be achieved, and the energy produced is utilized effectively to meet the power demands. Although these issues haven't been resolved fully, there are 3 strategies that can be thought of as an alternative. Fusion using magnetic confinement. One way to fuse the radioactive material in fusion reactions is by removing all their electrons by ionizing them and bringing them close in strong electromagnetic devices called tokamak. The idea is to bring the ionized atoms too close together in order to produce the superheated plasma of atomic nuclei that can be fused together. Although a tokamak is one of the most well-researched and cost-effective methods of achieving this, and nuclear fusion reactions have been demonstrated within two, the lack of attention and financing given to it has prevented it from being a commercial success. In order for the theory of magnetic confinement to flourish and tokamaks to be in widespread use, more research and experiments are needed to refine the procedure, but unfortunately, scientists are constrained from doing all this due to financial barriers. Fusion using inertial confinement. This strategy is greatly based on using raw force, as the idea of this method is to target pellets containing fusion-capable material with lasers from all directions to quickly increase its temperature and density until a nuclear fusion reaction starts. This method may produce great amounts of energy to even compensate for the energy input and produce surplus energy. However, lack of financing is also an issue. On top of that, controlling and storing the energy release is a major problem too, because the energy release uncontrollably can be severely dangerous, and hence the solution to storing energy must be known. Although experiments with this method have been successful and this method seems to be an efficient option for fusion reactions to take place, as mentioned earlier, lack of finance slows down the development. Third way approach. Many other competitors in the world of science are researching and working on primarily two alternatives to inertial confinement and magnetic confinement to enable fusion reactions. However, to everyone's dismay, their methods are far behind the break-even point achieved with inertial and magnetic confinement, which is why it seems as if these organizations are walking down an improbable path which relies on unlikely promises and technologies that are not even possible today. It is unknown how much close these competitors will get to achieving the break-even state for fusion reactions to sound convincing. However, their ideas are highly unlikely to ever gain success, but they're still at it. And rightfully, who knows, considering that nothing is impossible, it may turn out that these ideas, upon research in greater detail, turn out to be more successful and viable. Yet as for now, the scientific world is jumbled up and puzzled about the idea of commercializing nuclear fusion to the greatest advantage. The reason for the desire of bringing nuclear fusion into the industrial world is simply because of how clean and efficient the method is. And on top of that, it may even provide us with ways of hastening development without impacting the environment and provide a solution to cure worsening climatic issues. Nuclear fusion will also aid the constrained scientific world in conducting all the experiments scientists wish to conduct in order to uncover newer theories and technologies, which are not suitable to be conducted in current times of energy crisis. Therefore, we can only hope that something useful comes out of this research and that nuclear fusion becomes possible, because as of now, we seem to be standing far away from it, and the challenges are just so crippling. However, there are ample and overwhelming reasons for scientists to battle out problems in the desire of finding the optimum solution for using nuclear fusion reactions to provide an everlasting solution to the energy crisis. However, financing is also a major issue that is preventing scientists from hastening development. Billions of dollars are needed for adequate research and experiments to take place in order to make developments possible and move closer to achieving the correct strategy for making nuclear fusion a possible method. With that being said, this video has come to an end. Don't forget to share your thoughts in the comment section below. I hope you enjoyed watching the video, and if you did, do take a moment to subscribe to our channel and hit the bell icon to stay tuned. We'll see you in the next video.